Hey guys, this is Duke here from Los Torres, and unfortunately I couldn't make the presentation today, so I'll go over some of the parts that I worked on. I worked mainly, partially on the engine manager, which is the communication towards the back end, at least from the view of the player and the authoring. And one of the problems that I encountered with this was the management of the actors themselves. Actors are basically components of the game that interact with each other. And in the purpose of our game, we decided that because it's a tower defense game, these actors would be limited to enemies, towers, and projectiles. But we needed to manage the actors in such a way that we could manage the backend data, we could manage the backend data and also the JavaFX nodes themselves in a convenient way. And this also posed problems because the player itself should only be receiving the nodes themselves and not the base actor itself. Also, one further note is that the base actors do not extend the node and only compose the node. It's the JavaFX node, as Timmy and Chase may talk about later on. And so I created a range restricted collection object, which basically takes in the base actors, but it manages both the nodes and the base actors themselves simultaneously, so that in terms of code outside, it's much cleaner. And here we extend the group so we can add it we can add to the group basically, or add nodes to the group, and it also implements iterable T so that you can loop over the actors themselves. And here we say the collection itself is range restricted because we did not want to give access of every actor to every other actor. And hence we have the method getActorsInRange, which will give you basically all the actors within this collection in that certain range. Also, because we're using generics, this also helps increase efficiency because each collection will be for a specific type of actor, and this makes it so that if you only need information about certain types of actors, you can iterate over that type of actor rather than having to iterate over all three towers, projectiles, and enemies if you don't need it. And the other part that I worked on was basically the AI or pathfinding part of the project for the enemies. And as I already talked about the utility in class, I won't go over it in too much detail, but you implement basically 2 or 3 methods in order to use the A-star logic. And this A-star finder is extensible in such a way that our project actually uses it in a way that not only finds the shortest path from start to end, but it also avoids towers, or basically avoids where towers are. And this is extensible because other players or other developers might want to have ones that avoid projectiles. And here is a simple test that shows that the logic for the A-star itself is sound. And then here I chose random 50 starting points and random 50 ending points in order to show that, well, basically the logic is not only for our project but in general. And to show a concrete example of this in our project, let's run a AI game. And note that this is not actually like a good game, but it's more for the purpose of showing that the AI works. The enemies will start around here and end around here. There's 2 types of enemies rather. Blue balloons, which actually use the AI movement, and then there's Pikachus, which will literally just follow a zigzag path. So they will run into towers, whereas the blue balloons will try to avoid towers. So let's place one here. Here we see, and if we place one here, the enemies, the blue balloons at least, or if we place one here, the blue balloons at least try to initially avoid the towers themselves. And then as you saw, the Pikachus kind of just ran across. But that's basically what I wanted to demonstrate in my part of the demo. And have a great winter break.